In our study of kinematics of linear motion, we will be facing many kinematics quantities. So what are kinematics quantities? They are physical quantities that we use to do kinematics. That's the idea of kinematics quantities. So over here, I've listed down a few, and we will go through them one by one. Okay, so the first thing that we are going to study today is the kinematics quantities called position. Okay, position, usually we describe it with a vector x if it's moving in the x dimension, a vector y if it's moving in the y dimension, or a vector r if it's moving in both dimension or even 3-dimension. Okay, if it's 3-dimension, usually it's x, y, and z. Okay, so this is the vector form for position, and we always define our position with respect to the origin. And in the previous video, we've already mentioned what is origin. Okay, and origin is usually also the starting point for a certain motion. We usually start the motion of something at the origin, but it's not always the case, but it's most of the case. Okay, but that's not our concern. We'll leave that for displacement later. So let's say today I have motion in the x dimension. Therefore, I'll be using the x-axis to study the motion. Okay, so today if I have a person over here standing at the origin, then I'll call the position of that person to be x, vector of x equals to 0. Okay, I put 0 here because there's many examples that I'm going to show you. So for now, it's standing at the origin, so the position will be equal to 0. If let's say this person moved towards this position over here, and if we measure its head, it's connected to like 4, and we call the vector, the position of this person right now to be x1. Okay, we measure with respect to the origin, so the position over here is measured with respect to the origin. So you can think of the origin as the first point, the current position as the second point, so you draw a vector like this. Okay, so this vector here we can describe it as 4 meter. Now because our axis is in meter, so this will be 4 meter towards the positive x direction, because this vector is pointing towards the positive x direction. Okay, another example, let's say now it make a U-turn and run over towards this side. Okay, we don't care how it arrived at this side, but now it is at this position. So let's define the position right now. If we define a position, we check what number is it on? -7. It means by our vector will be pointing from the origin towards the current position right now, and we label it as x2 because we have x1, we have x0 already, right? So this is x2, and if you want to define the position, it will be x2 equals to 7 meter towards the negative x direction. Because when we say vector, we usually write the magnitude without any sign, right? Okay, the magnitude of a vector is always positive. So if you write the magnitude only, it should not have any sign. Okay, so 4 meter, 7 meter here are magnitudes, so it's always positive, no sign. But we include the direction down here saying that it's towards the negative x-axis. So that's how we define the position of an object, in this case at various times. Okay, but actually, since this is a vector form and we write the direction this way, it's actually quite rare that we really write things this way. Because when we want to take, let's say we want to take x1 plus x2, then it will be quite troublesome to add the direction together. But if you remember, if you want to sum up vectors, what do? We resolve to its components, right? That's why when we are doing kinematics question, it's usually easier for us to write things in terms of components instead of its full vector. Instead of writing the magnitude and direction like this, we break it down into its components. So usually, let's say for x0, we'll just write x0 without the arrow sign indicating this is not a vector anymore. Then we just write the value. Then for x1, you just write 4 meter. And for x2, since it's in the negative x direction, you provide the negative. Just like how we resolve vector. If a vector is in the negative, if you resolve it is in the negative x direction, we put a negative sign, right? Here, of course, the vector is already in the negative x direction. If you resolve it, there's only x. So since it's in the negative x direction, so you put a negative sign. Okay, for x1 is in the positive x direction, that's why it's positive, but positive you can omit it sometimes. Okay, so now you might be thinking, resolve. Okay, Mr. Gunn last time told me that if I resolve A, if I resolve vector A, if I resolve it, I should be getting AX and AY, right? But why over here I didn't write a subscript X over here? Why didn't I write it as X0, X, X1, X? Why don't I write it this way? Well, it's not that you can't, you can actually do it this way, but it's logical already, right? If we write our symbol as X already, it's very logical that it's in the X-axis already. So we don't need to write a subscript X to, it's redundant if you put it that way. Okay, so here's writing it in components, here writing it in vector form. In calculation, we do it in components. If they ask for the final answer, then you describe it this way probably. Okay, so let's move on. So let's say today I have a certain position, components of the position. Okay, this is X component of the position. And let's try to study what happens if the sign is positive, what happens if the sign is negative. Okay, so this is our sign over here in front. If our sign happens to be positive, it means that it is on this side, right? So it means if this is the origin, it is on the positive side of the origin. So positive here means on the positive side of the origin. If it's negative, it means it is on the negative side of the origin. Any negative numbers for our x, if you have a negative sign, it must be on the negative side of the origin. Okay, let's move over to this absolute value part. Absolute value means that we study only the number without looking at the sign. Okay, we'll study the number only. Okay, so if the absolute value is increasing in time, what does it mean? It means it is moving away from the origin, right? Because if you go from 1, 2, 3, 4, 5, 6, 7, you are getting further and further away from the origin. Same over here. If you look at the absolute value, just look at the value, don't look at the sign. It's also 1, 2, 3, 4, 5, 6, 7. So you're moving away from the origin if your absolute value increases with time. Okay, if your absolute value is decreasing with time, means when you go from 7, 6, 5, 4, 3, 2, 1, or over here 7, 6, 5, 4, 3, 2, 1, you are getting nearer, or you are moving towards the origin. That's the idea. If you see the composition is decreasing with time, it means it's moving towards the origin. Okay, now that we know how to study the absolute value, how to study the sign, let's try to study what will happen if our x component of position here, this x here, is positive and increasing with time. If our x here is positive and increasing in time, what does it mean? It means it is positive, so probably somewhere on this side of the origin, on the positive side of the origin. And if it's increasing, it means it's moving further away, right? So if it's moving from here to here, you can see that the object here is moving in the positive x direction. In this case, it's moving to the right, and right is the positive x direction. Therefore, we say it's moving in the positive x direction. So if we see the sign to be positive, and we see the value, the absolute value to be increasing with time, we know that this object here is moving in the positive x direction. That's what I'm trying to say here. Okay, now if you move on, if the sign is positive, but the value is decreasing with time. So this is a very good example. You have a positive value here, but this value is decreasing with time. So it's moving like this, okay? Decreasing with time. From 4, go to 3, go to 2, go to 1. All the time, it's always positive. So you can see that the object here is actually moving in the negative x direction. Okay? Next part. If it's negative and it's increasing with time. Negative means by it's on the negative side of the origin. So all these region here are negative. If your object is at any point over here, you should get negative. But if it's increasing with time, if the absolute value is increasing with time, you should expect 4, 5, 6, something like that, right? Increasing. So if you see if it's negative but the absolute value is increasing with time, you can see that the object is moving to the left. So the left in our axis here is the negative x direction. So if you see negative and increasing with time, you know that it's moving in the negative x direction. Okay, last one. If it's negative but it's decreasing with time. So over here you can see it's negative, but the absolute value gets smaller. Let's say from 4. Okay, the absolute value is 4, decrease to 3, 2, 1. Okay, the value is getting smaller and it's a negative sign. Then you can see that it's moving to the right. If it's moving to the right, that means it's positive x direction. Okay, so when we're studying about position and how it changes with time, we study both the sign and we study the absolute value, whether it's a positive or negative sign, and whether the value is increasing or decreasing with time. By combining these two information, we can know whether the object is moving to the positive or the negative direction.